Welcome everyone to today's webinar. I'm really excited for this topic today. We'll get started on time. The topic for today is AI-driven development in .NET, and excited to jump into this. We've given a few teasers in some previous webinars, and it's even been a module in our .NET Engineer and Architect Bootcamp that we did at the very beginning of August this summer. But this is a full webinar on AI-driven development in .NET. Um, if you haven't seen before, we've also done some webinars on um, AI architecture and also DevOps automation for AI, and you can find those in our webinar archives. But this one is purely about AI-driven development. So let's jump into it. Okay, three-part agenda when it comes to covering the topic of AI, and we can't possibly cover all of it in just the short amount of time we have here. And so when it comes to creating software that uses generative AI, we're just going to do a bit of an overview just to set the stage. But making some features that use a large language model, and whether it be a chatbot, whether it be an agent that's running under the covers, that's its own category of AI usage. The second is AI-driven development. That is using generative AI to create software. We are creating software. If you are a software engineer or if you run a team of software engineers, you want to use the power of generative AI to create software, do it faster, better, more consistently. And so that's what we're going to dive into deeply today. And then the third is using autonomous agents to develop features. We're going to cover that in the future. We can't jam pack all of that right now. And if you've heard announcements about GitHub's coding agent and other tools where the agents kind of run off to the side in the background and then they pop up with a pull request, we're going to cover that in a future webinar. But right now, in this webinar, we're talking about software engineers doing AI-driven development by using the tools that are built right into the IDE. We're going to be using Copilot today, and Cursor's another one that's gained popularity because they did Cursor as a fork of VS Code with just a different coding tool in there. And then also the JetBrains IDEs have the Junio AI agent, and there's more to come. But we're going to be using GitHub Copilot today, and so that's what we're going to do. Um, if you have not received a copy of my latest book, The Five Pillars: Leadership for Effective Custom Software, I highly encourage you to give it a read. It's an easy read. It's not a terribly thick book, and it is for people who are running software teams. It is for lead engineers, architects, first line software managers, and if you would like a free electronic copy of the book, then just you can request that in the chat or send me an email, and we will be happy to get you one. Okay, we just have less than an hour with each other today, but if you and your team are gearing up for full-on AI-driven development, then you should bring your team to Austin, Texas, December 8th, 9th, and 10th. And we are doing a 3-day in-person bootcamp training course specifically for AI-driven developers. And this is not a learning to program course. This is not for people who are not proficient in .NET. We're looking for the people who already have mastered .NET and C# and are looking to gear up for AI-driven development. So December 8th, 9th, and 10th, I am the instructor. It's going to be really, really fun, and we are going to write a lot of code. Boot camps are not just lectures. This is an immersive, intense boot camp style training, 3 days. and you're going to write a lot of code. We just did a .NET Engineer and Architect boot camp training course about a month ago, but this one is all about AI-driven development. And I already talked about getting that book, so we'll move on. Okay, so um, let's just set the stage. We want to make sure we understand um, the AI technology that we're working with, and it's important to remember history. Back in 1956, um, John McCarthy and a few other researchers, they did a summer program, but John McCarthy, it was his brainchild at Dartmouth University to do a summer program, and he needed some funding. And so he made the pitch to request funding for this summer program, and his hypothesis was around artificial intelligence. And he defined the term AI as the conjecture that every aspect of learning or any other feature of intelligence can, in principle, be so precisely described that a machine can be made to simulate it. And I want to highlight precisely described because we still have to do that today. And we see so many machines that are simulating things that previously only humans could do. They're an aspect of human intelligence. And artificial intelligence, if something is still called AI, it's because we're still trying to figure it out. And there was a time before cars had adaptive cruise control, but if you think about it, once something is mature, we give it a product name and we don't call it just artificial intelligence. We don't call it cruise control AI, but adaptive cruise control, the machine looks at cars in front of us and actuates the accelerator and the brake. That's what it does. Same thing with GitHub Copilot. I fully expect at some point that we'll just call it Copilot, or maybe they'll refine the name. But we are precisely describing some aspect of human intelligence so that we can make machines that simulate it. Okay, local LLM tooling. I'm going to give a couple of demos, and you might want to just do a screenshot and look at these URLs, github.com/Jeffrey Palermo and /Clear Measure Labs. There's some code that might be interesting to you. I'm going to show you the AI semantic kernel soon, but um, if you're gearing up for AI-driven development, you can do everything in Azure, OpenAI, or GitHub, but you're also going to want to run some of the open source models locally so that you can do some testing. Um, and so you'll want to have some requisite hardware. You'll want to have LM Studio installed, and you'll want to have Ollama installed. And just so you can kind of see what it does, if you've never seen Ollama, then I'm gonna show you the user interface. It's a very simple tool. I highly encourage you just to go on the website and uh, install Ollama, give it a shot, and actually let me not there. You know what? I'm gonna do it when I do demos. I'll show you the Llama screen. But those are the two pieces of software. Okay. Um, when you're thinking about hardware, you're going to want a GPU that is, maybe the top half of this chart. The RTX 4090 and then the 5090, they're definitely the king of the hill. The I've done a lot of testing, and on my computer, I have the 5080. The 5080 is about equivalent to the 40. No, I don't have the 5080. I have the 5070 Ti, which is roughly equivalent to the 4080. So they have some strong parallel. And I'll actually show you the memory on that. So let me come over to here and show you my performance tab. Okay, here we go. So It is the GeForce RTX 5070 Ti, and of course, it's not doing much. And it has 16 gigs of memory and the of GPU memory. And the important part is the memory bandwidth. And so the 50 series has the next generation of memory. And the reason that the the 5090 and the 4090 are so much faster is because they have double the GPU memory. It's all about how much memory you have because there's some models there's some models that I can load just fine on this computer, and then there's other models that won't even load because they require more GPU memory. So when you're looking at the numbers and trying to figure it out and the number of CUDA cores, that doesn't make as much difference when you're running locally as the GPU memory. So I think in today's day and age, you can do some of the smaller open source models with 8 gigs of GPUs memory, but 16 gigs gives you a lot more flexibility. And then if you're actually running a server where you're going to be running some of the models yourself or on a VM, you want to have that 32 gigs um, and have the top tier. Okay, so let's go back here. All right, a little bit of architecture, what's actually running when a large language model is on the computer. Again, I'm just doing the overview here. Um, I like to compare it to a SQL Server database. You have you have a database file, and then SQL Server opens the file, and we communicate with SQL Server, passing in a query, and then we get information back, and we use a library entity framework for translating the request and the response to objects. Same thing with an LLM server. The model file is on disk and we never open it. We use Ollama, which is a LLM server, to open the file, and then we send a string, which is the prompt, to the LLM server, and it gives us back a response. But we don't put it together manually. We use libraries like Microsoft Extensions AI to craft the prompt for us and then interpret the response coming back. So very similar to Entity Framework with SQL Server. And just like Azure may host SQL Server for us, and host the MDF file, Azure may also host the LLM server for us and host the model file. So it's kind of a very similar architecture, except the LLM servers are read only, whereas a database is read and write. And we can go to any LLM server provider with, say GPT-4, GPT-5, and we're going to get the same model. But the LLM server from Azure and others, they just may put a few different filters on it or have it unfiltered. So that's what's going on under the covers. And GitHub Copilot is just going back and forth to Azure OpenAI. In your code, just like you would, let me go back, just like you would have a Visual Studio project with your data access code, if you are writing some code that makes use of an LLM server, you want to have a Visual Studio project so that you can manage the library dependencies so they don't get all mixed up and you end up with libraries in your UI projects. So Microsoft Extensions AI, Ollama, OpenAI, all the libraries that you may use are going to be referenced by one of your Visual Studio projects, and you want to have a project to isolate those dependencies. Okay, so that's the overview, and then we're going to dive into Copilot for the entire rest of the time. So I'm going to show you semantic kernel and some of the techniques and AI tools. So let me come over to Visual Studio, and I have a test project, and you can get this code. I'm going to just run it with my ReSharper runner here, so it's fresh. And we have some test cases. This is a test project, and these tests are running, and some of them are running against Azure OpenAI in the cloud, and some of them are running against Ollama locally. And I'm going to actually run them again just so that you can see that my GPU actually does a little bit of work when the ones running against Olama execute, because that's running locally on this computer. All right. Now, if you run it on your computer and you don't have a 16 gigabyte GPU, then you're probably going to resort to the CPU runtime, and because we're loading Llama 3.2, which is just a little bit too big for an 8 gigabyte GPU, and then it'll run CPU and they'll run quite a bit slower. But AI semantic kernel, if you're writing production AI code right now, then you're going to have the most luck using semantic kernel. It's been around for a while. Microsoft is in the process of refactoring all these libraries into the Microsoft Extensions AI family of libraries. But you'll notice if you using those, some of them are marked pre-release and they're deprecating things and moving some things around. But the future of all these libraries is Microsoft Extensions AI, and it's kind of replacing, or it's absorbing, the functionality that has been in the semantic kernel libraries. But let me show you in code what happens when you do chat. So I'm going to open up. Let's see. I'm just going to open up regular old Copilot, and let me see here. Bring the window over. Okay, this is regular Copilot, and I'm going to say my name is Jeffrey, and then what is my name? Okay, and the chat context. If you use ChatGPT, you know that everything that you've put in, it recalls. Oh, how old am I? And of course, there's no way for it to know. But if I ask, well, let me go over to the code. So in in regular chat mode, the entire context of the conversation is kept in the chat context. Well, what does that mean? Let's dive into what it means in code to replicate that. So let's go here. All right. So I have a method that is basically 5 in-unit test cases, and this is going to simulate a chat. So in order, we are going to add the prompt, which is hello initially, and then my name is Jeffrey. I am 45 years old. Liana is Jeffrey's wife. She's 1 year older. How old is Jeffrey's wife? And we expect the number 46. And so the first test is going to add the prompt, which is hello, to the chat history. Chat history actually comes from the base class. I'm going to go into this just so you can see chat history is right there, and we're kind of initializing it. We're initializing chat history with a system message, only respond to the user with single word responses. Okay. So get rid of that. And of course, it just pulls over environment variables for how to get to Olama, the little helper class. And so using semantic kernel, we're going to get our iChat completion service. And then we're going to get chat message contents, passing in chat history. Well, the first time we run this, it only has hello. And then if should assert, which should assert is going to be false for all of them except the last ones. So all we're doing is building up a chat history. Hello, my name is Jeffrey. I'm 45 years old, and we're running it every time. But the last time that we run this, chat history has all 5 of those. And so then it can do what we expect it to do. So let's run this, and you can see it runs them in order. So 1, 2, 3, 4, 5. That was very quick. And the last one is, and ReSharper doesn't actually preserve them in the proper order, which is unfortunate. But the last one to run is this. And let's see, there it is. Okay. So what we can see, I turned on the logging for the prompts, and what we can see is that when we invoke this, we have the role of system, and we preloaded it with only respond to the user with single word answers. Okay, that's how we add system prompts. That's how you can make the certain prompts take priority over the user prompts. And then we have another message, a user message that was hello. Then we have another user message, my name is Jeffrey. Then we have another user message, I'm 45 years old. Then another one, Liana is Jeffrey's wife, 1 year older. How old is Jeffrey's wife? And so we're using Llama 3.2, and the assistant is responding back with 46. Okay. And you can see for debugging purposes, the input total token count is 72. So if you're doing things like this and you want to budget, you can see that it consumed 72 tokens, and you can figure out, how many of these per hour per day you're gonna execute, and then you can do the math and figure out how many tokens you're gonna need to buy. Okay, so that's just chat history. Tool injection is is another interesting scenario, and I'm going to show you. I think the end of here should. There we go. This is the one we're going to run. So I'm going to run this guy, and every once in a while, Llama doesn't, or Llama 3.2 doesn't follow instructions because we said single word response, no punctuation. Well, we expected yes, but the response was grandpa's age is older. Well, it got the answer right, but not the format. And so in code, we really need to control that. And Llama 3.2 is known for not being perfectly consistent on following instructions. Actually, if you read up on documentation on the different models, the ability to follow instructions is one of the characteristics of these models. And so if we were just to run this again, then okay, now it passed and it's just fine. But the prompt here is grandpa's age older than Liana's age? Well, how is Llama 3.2 or any model, how is it going to know that? It doesn't know that. That's where entry points into our system come from. And so with semantic kernel, what we do is we import what's called plugins from other classes. And so if I'm gonna dive in here, this is just a class, and we can give it a description, and we annotate it with kernel function, and it is arbitrary code. So this code could be an entry point into your data access layer that queries your database or calls a web service or literally any entry point into your system. And right now we just have it hard coded for if it's Jeffrey, return 45, if it's grandpa, return 81, etc. So I'm going to go back, and when we call this, we have the function choice behavior being auto. In other words, we let the model know that there is a demographics kernel function available, and that it is available if it's useful to call. Okay, so let me run this again, and then we'll see what's happening. Okay, so the user is grandpa's age older? Well, then the model requests calling of get person age with grandpa and get person age with Liana. The model requested the callback. So semantic kernel, the library running in our memory space, does that and then does another round trip and uh, calls it with the chat history and returns get person age of 81, get person age of 46. And now the model can come back with an answer of yes. And the second round trip uses 167 tokens. And the first round trip uses 224 tokens. So you'll have to add those together. Okay. So those are tools, and that's how you register tools. Okay. Let me go back to the slides now. Okay. All right. Now, so that's where LLMs sit. Now let's dive into Copilot, and dig into the practices of AI-driven development. And I want to highlight something that Jeff Sutherland mentioned when I interviewed him on episode 317 on my podcast, the Azure and DevOps podcast, and he said extreme agile is Scrum and AI. Now, Jeff Sutherland is one of the creators of Scrum, and he said the genesis of it he was in the Navy in the 70s. and and uh, and he predicts that by 2030, teams will be 30 to 100 times faster. And this guy's been around a long time. He's seen the different trends. He was he was well into his career before desktop computers were common and well before the internet came around. I started my first programming job was in 1997. So I saw the uptick of the internet and then smartphones and then the cloud and now AI. But Jeff Sutherland has seen a whole lot more. And also episode 351, Scott Hunter, who's the vice president over all of the .NET tools, we talked about AI-driven development specifically, and I highly encourage you to watch that because you can see his vision for where they're trying to take it at Microsoft. So when we think about AI-driven development, I want you to remember a few things. Uh, the concept of coding forward and tools like Copilot, ReSharper, and other productivity tools, and the requirement for architecture standards, design patterns, and consistency. I'm going to come back to those, but I want to put those in your brain. Okay. Now, as we dive in, and we'll get back to a demo, I want to anchor your mind for where this applies. And I want to kind of overview the business of custom software. So when we're going to do a software project, we start to think about when tackling the business problem, we think about designing a software solution. We got a business problem and we think, what kind of software would solve that problem? Or what kind of major feature? What kind of system? So we design the software solution. But then in order to actually make it happen, we have to design a project that can deliver the solution. Do we break it up into phases? Do we need to do certain features or capability first in order for other capabilities to build on top? We have to figure out the major sequencing of implementation and scheduling. That's designing the project. Then we have to design a team that can execute the project, a team that has the proper skills, that has the proper tools, that works a certain way, that can execute the project. And invariably, if we already have a team with a certain set of tools and process, sometimes we design a project that kind of fits with the team we have. That's perfectly fine too. But we have to do these things. We have to make these macro level design decisions so that we can start working. And that's the role of the architect. The architect, sometimes we mistakenly think that the architecture of a software solution is just the shape of the resulting software, but it also is the project. This is also the sequence of what things we're going to do first and how it fits together. And it is also making big decisions about how the team is going to work. Okay. Once we've done those three big elements of design, well, now we can actually execute the project and start working, and we can empower our project managers to actually manage the project because there's actually something to manage. Um, and as we execute, we measure, we forecast, we adjust because of what we measure. So AI driven development, we can set the stage when we're designing the software solution, when we're designing the project, and we're equipping the team. We set the stage for AI driven development. And then the inner loop is executing, developing features, coding, testing, deploying all that developer inner loop and pull requests and feature branches. And so that's where we kind of see the tools that empower AI-driven development. But we have to think about equipping our team. We have to think about projects that may be a little bit different. We have to think about the shape of the software and how to segment the actual resulting software to empower these AI tools. I'll talk about some of those as we go through this. Okay. Um, if you are still manually testing some parts of your software, and if you're still manually deploying parts of your software, you are going to want to address that problem so that you can adopt AI-driven development. AI-driven development, and I don't have time to go into why and are there any mitigation steps. AI-driven development requires test automation. It requires you to have that safety net to know if with a certain code change, if we somehow destabilized part of our system. Okay, that's a requirement. It's just a prerequisite. An automated DevOps environment is a prerequisite to AI-driven development. And so um, if you haven't automated your DevOps environment, you need to do that. If you are not automatically deploying to every environment, I'm talking about deploying every part of your system, including your databases and file systems. If you're not automatically deploying, you're going to also want to address that because if we have more pull requests more frequently, more builds, more deployments, you absolutely need to have those automated, or you're just gonna, move the bottleneck and you're just gonna have a queue of builds waiting to be deployed to a test automation environment, a manual test environment, and then ultimately to production. All right. And let me put it this way from a process perspective. With AI-driven development, we are crafting prompts and we are asking a computer to generate some code that we would be happy with. And when you create a work tracking board in Azure DevOps or in Jira or anywhere, oftentimes you get a very small handful of columns. And sometimes there's a backlog or to-do column. Sometimes there's maybe a ready for dev columns. Sometimes there's an in progress column and there's a done column. That's it. And oftentimes a engineer will grab a card, move it to the in progress column, and then start thinking about pulling together all the analysis information and maybe screen mock-up if it exists, any kind of information that would make it clear what the proper code would be. If we're going to ask a computer to generate this code, then we have to have all of the relevant information about what the right code would be pulled together in one place. And so our process needs to um, make sure that we're gathering all of the relevant information. So uh, ahead of development, ahead of the code, there are four big design decisions where we have to capture information. That is the business concept. You can think of it as part of requirements. That is, why are we doing this? What's the deal? What are we trying to accomplish? And then the user experience design, uh, is there going to be a button to click? Do we have text boxes, drop downs? How is someone going to use this particular feature? And then we have technical design. What libraries, what design patterns are we going to use? Is the current architecture up to snuff for this new feature? And then in test design, we have to enumerate what is in scope and what is out of scope, so that we know how many different pathways through the code need to be tested. Okay. So, in the future, if Jeff Sutherland is correct, then the amount of time we spend in this development column is going to shrink, 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 shrink. And I think the ultimate is it's going to shrink down to the point where we can lay out the code and we can deliver features at the pace that we can think about what the right feature is, or the pace that we can think about the right details of the feature. So if this development column shrinks and shrinks and shrinks and shrinks, that still doesn't make software automatic. Why? Because we still have to have conversations and think about why we're doing something and make sure we have clarity on the concept. We still have to figure out how someone is going to use the software, what their experience is going to be because that software feature is present. We still have to figure out what design patterns and libraries we're going to use, and we still have to figure out how we would test said feature when it's actually done. Okay. So all this work is still there, and we don't see, any hint at that just magically being automated. Right now, what we are trying to do is take some of the mechanics of the code writing and reduce the mechanics so that we can deliver faster once we have clarity on what's the right feature to develop. So let's do that. All right, let me go over to Visual Studio, and we have actually, let me close this one. Let me pull up. We have a application. Make sure I'm on the right one. Yep. We have an application that is a work order management system, and let me just run this with Control F5. And you can see that it is Simpsons themed, if anyone remembers The Simpsons. It is the First Church of Springfield work order system. We're going to log in, and we have pretty open security. We're just going to select who we want to log in, Reverend Timothy Lovejoy. And he can go and create a new work order and assign it to somebody. But I'm going to actually search for a work order and, select one. And of course, we have a chat agent built right in, and let's see, what is the title of this work order? We can do very simple things, and it's connected to Olama. The title of the work order is, um, and whatnot. But that's what this does. So the work order has a title, a description, what room, and some other things. So let me get rid of this. And in our work tracking board on Azure DevOps, notice that we have our Kanban board, conceptual definition, UX design, tech design. We have two cards here. We have add work order instructions, and we have auto cancel background agents. Let's just look at the first one. We have the concept. The maintain work order screen needs a new field instructions. Okay. Let's see, UX. The instruction field should go right after description, multi-line text box, support 4,000 characters. Okay. Tech design. Let's see. It's going to be a string. Okay, we want some unit tests. We're going to be using Entity Framework, so we need a data access integration test. Database changes, need that integration test, new change script, and we need to add instructions field to the screen with new acceptance test. Fantastic. And the test scenarios, one test scenario. If we can create a new one, yep, only one test scenario. Okay. So I've already created a feature branch, but I'm gonna copy. At some point, I expect Copilot to be able to automatically read the contents of the issue in Azure boards, but for right now, it doesn't do it. So I'm gonna copy that information, and I have a clean branch here with clean branch 828 add instructions, and actually it doesn't matter what file I have open. So I'm going to um, paste this in and then give it instructions. Implement this feature. Okay, and I'm using agent mode GPT-5, and it is going to also start reading Copilot instructions, which I'll come back to, and it starts reading things. Okay, while that's going, I am going to come back and I'm going to see what this other feature is all about. And this one actually has a lot more information, and it looks like there were some conversations that happened, and Copilot was used in helping to generate the spec. And I'm not even going to read it all, but the gist is we want an AI-driven background agent that evaluates assigned work orders and cancels those. So the gist of this is if the work order was assigned more than 24 hours ago and it's like test or demo or temporary, then we want to automatically cancel it because it was just a test or a tracer bullet and it's kind of junk and it's cluttering up the work order system. So let's go ahead and look through this. Okay, so we're gonna we're going to say, you know what, let's go ahead and name it this. Let's register it as a background service. And by the way, when we have new architectural concepts, we tend to need to uh, enumerate our plan. And when we verbally gather around a whiteboard, we do this anyway. So this is just capturing it. So I'm going to copy that and let's get another instance of Visual Studio going, which already is on a separate feature branch. And let's see if we can create a new context and let's just, let's see, modified. I think, well, let me make sure we're clean here. Build completed. Okay. And let's paste that in and let's get going. All right. Let's let that churn. Let's come back to this other instance of Visual Studio and see how it's doing. And okay, it's still reading context. And so with AI-driven development, you're going to find yourself waiting on GitHub Copilot or Cursor or whatever tool you happen to be using. And sometimes they get stuck and you have to push them a little bit more. So if you don't see activity, sometimes you have to um, get it going again. So I'm looking for signs of life because I might have to restart this. Let's look at the other one. This other one is going. Read work order, read program. Okay, this one's going. Searching client factory. Okay, let's come back here. Ah, it's going. Okay. So it was just a little bit delayed. So you see it's reading. When I mean this is a big feature. This is going to require changes to multiple files and any of you that have played around with GitHub Copilot, it does a fantastic job already modifying code within a single file. But when we are developing features, we are bouncing all around the code base. And so we have to figure out how to get the tool so that it'll be successful at making changes all around our code base. And just remember, Copilot is all it's doing is pattern matching. It is a language model under the covers, and you see, we are giving it a prompt. By the way, everything is in the prompt. So it read Copilot instructions, which is right here. Everything that it reads, and you can go to the Git repository and see what text is in this Copilot instructions. Copilot instructions gets added to the context. And then the prompt that I typed, the spec of the actual feature gets added to the context window. And then it executes some tools to read snippets from files which get added to the context window. So imagine this chat history that is just getting amended with another file, another file, another file, another file, 18 files read into the chat window. And now we see some output, planned changes. And GPT 5.1 or GPT 5 is a reasoning model. And so it tends to plan things before it executes. But you can ask Copilot to plan it out first if you want. But let's look and what does it have? Plan changes, work order. Okay, so it's done a number of things and check, update. Okay, so now it's summarizing. Now it's summarizing more things. And I have found that Copilot will do some things and then it will tell me some things to do next. And if I look, I can tell that it's not done, but it says run the build and test after applying the above edits. And so I'll have to come back and say, do the suggested tasks. And just, I have to get it going again. So now come back to the background agent, the auto cancel agent. And what do we have here? We have that it planned it out. Yeah, delay files. Okay, so it planned everything out and now it has a plan. And so I'm going to say, do it. Okay. All right. So now I think it's going to It's going to get going. Again, it always reads in Copilot instructions. So whatever you have in Copilot instructions markdown, it's going to get read into the context window and be part of your prompt. All right, let's come back to our adding instructions. Let's have this going. And by the way, the the we're not going to go into the automatic GitHub coding agent that can run at GitHub, but you will know that you're ready for that type of autonomous agent when you can have multiple Visual Studios going at the same time, and you can just kind of keep them working, and your requirements and spec and design process has gotten enough detail, and your code base has enough consistency and enough patterns in it so that you're kind of overseeing the code instead of typing the code. And by the way, you can keep a few of these going, and you can, be working on a architectural proof of concept in a third Visual Studio instance on yet another branch. Now you do have to clone the code base multiple times, but it'll be a separate branch. All right, and you're kind of checking on these. So if we come back to this guy, we can see, oh, we had this file open, so we can see what it's putting down. Okay. Add tests. Okay. Um, complete the rest. You just got to bump it. You just got to bump it and say, keep going. Okay. What do we have here? We're still doing some things. We can spot check, by the way. Um, so if we go up here, we see instructions being added. Up here's some HTML. There we go. We can see the code behind. We can see instructions being added in the right spots. In our work order entity, we can see the instructions property. Now, this is interesting. You see how it says get truncated string? Well, everything, we're going to get more code like the code that we have. And we have description, which is also a 4,000 character, and it had the pattern of get truncated string. And so it said, it must be another one of that. So with Copilot, you're going to get more of the code that you already have. If you don't like the code in your code base, then GitHub Copilot is just going to give you more code that you don't like. All right, let's look at work order tests. By the way, we have good tests in here. Okay, should truncate. We got another unit test, nice and easy to read. It's creating a new string that's 4001, and we're making sure that it truncates, and then we're augmenting some existing tests to populate instructions, or yeah, okay, database script. Do we have our database script yet? Yes, we do. Here we go. 022. We are using AliasQL for SQL database change management, and we can see the sequence of database changes right here. And we have one alter table work order add instructions 4,000. Very good. That's what I would have written. Next steps optional add acceptance test. That's not optional. That was part of the instructions. So continue with next steps. You just got to bump it again. All right. And let's go back here. Does it think it's done? Nope, it's still crunching here. But let's review. Okay, unit service. Work order evaluation agent. All right, this is a big one because this is a brand new background service. And it is, let's see, what's it doing? Should I cancel the work order? Okay, so we're going to say if it contains test or demo or temporary, if it contains any of those. Okay, if yeah, work order is assigned and we're getting the dates. Okay, let's go to auto agent cancel service. So this is a background service. That's good. And the background service is executing and it's creating a new scope. That's good. It's using our existing bus pattern and it's looping through and assign to cancel command. Yep, this is the command that our application supports to cancel a work order. And let's see, does it think that it's finished now? Recommend adding tests for scenarios. Okay, great. Complete recommended steps. All right, let me go back and check on this one here. Completed next steps. All components implemented. Let's see what it did. Work order instruction tests. So this is a playwright tests, which I'll show playwright test, and it is should create work order with 4,000. Okay. We're waiting for page, which we'll come back to this later, but it's I can read this code. It's in one. We'll come back to it later. And do we have okay, work order map? This is our entity framework code. And it found the actual map class and added one line item to our entity framework code. Then work order tests is our unit tests. Then do we have, yep, we have work order mapping tests, which we have a brand new integration test. Let's go up to what it changed. Those lines. Oh, it found the existing test and just modified the existing integration tests that round tripped this object to the database. And okay, before we think, is this feature fully implemented? Inspect everything. All right, that's what I tend to do. Okay, let's go back to our agent. What does this have? Build past. Okay. Is this feature fully implemented? Inspect everything. All right, let's let that guy go. All right, so it's reading, and if it thinks that everything's finished, well, then I'm gonna run the build, and I'm gonna make sure it works. Okay. And let's see. I think did we start at around 2:20? So we have two features. If we can get two features implemented in half an hour, that's probably faster than I would have taken to code these features myself with multi-layers of test automation and whatnot. So let's see which one's going to be finished first. Is this guy? Okay, so I'm going to hit keep and let's just Control Shift B. Let's see this guy. Build complete. I'm just gonna run unit tests right here to make sure that it didn't break any tests. Okay, unit tests are good. Integration tests, let's run those. And so we had 100 unit tests. We have 39 integration tests. Okay, and kill the orphan resharper process. All right, let's see. What's it? Built to ensure deployment pipelines apply the new script, which they will. Okay, so I'm going to keep everything here and I'm going to Control Shift B and I'm going to run my unit tests. And we're going to run the application. We're going to run the private build and run the application for this one because this is cool. This is a good demo. All right, let's make sure we didn't. Hold on. Hold the phone. What do we have here? We have some failing tests. What does it say? Invalid column name instructions. Well, yeah, because our local database doesn't have that file. We created the alter table. So let's go to, let's see here. Let's make sure we're in the right clone with source, database, scripts update, and the 22. Yep, 22 is there. So let's go back up to the top, click to build.bat. It runs our build.ps1, and this is going to run our new SQL script. It's going to update our local database, altering the table and adding that column to our schema or unit test. Okay, there's our database, 022. And see, this is why DevOps automation is absolutely critical for AI-driven development, because if you don't have DevOps automation, then you can't do this stuff. All right. So now we just ran all the integration tests. We know that they passed. Let's run the actual application and let's see instructions. Uh, okay, looks like operations not valid single API. And looks like we have a bug. Okay, so it didn't do it perfectly. And we have a bug 19. Okay. So we're gonna have to sort out that bug. But all the tests, so it's probably something with the web or serialization or something. Okay, and let's see work order. All right, let's see the other one. This is complete. All right. And okay, let me so we have our code here, and there's one bug, and there's one bug to sort out, but we didn't break any past functionality with our tests. So for time, I'm going to go back to the slides because I want to get in a few things. And so it's not perfect, it's fast, it's pretty darn close, but you got to babysit these things. Okay. All right. Um, Staying in the AI tool sweet spot. So there are some studies out there, and I included the URL arxiv.org. Just do a screenshot of this, and it actually ran developers through using Cursor Pro, which is a VS Code clone, and it found the sweet spot was coding tasks that would have taken around 2 hours, that we got a little bit of improvement from. But if the task is going to take less than an hour anyway, this study didn't see improvement. And if the task was going to take longer than 8 hours, then there wasn't any improvement. Also, the study kind of broke down the amount of time reviewing AI output, prompting. So this is new work, it's green, versus active coding. So active coding reduced a bit, reading and searching reduced a bit, testing and bugging reduced a bit. So it's interesting that we're starting to study these things. That's very, very early. GitHub Copilot agent mode just came out in May, so we need time to study these things. A Stanford sponsored study in 2025. And by the way, I highly encourage you to go look up Jaeger Denisov Blanche on YouTube. And they discovered they last year. Now this is just using ChatGPT and Claude and Cursor, things where you would have to copy and paste in the code. The integrated Copilot agents, these really haven't been studied at all. But they're with any of these agents, if we don't get the code we like on the first try, then we're going to end up doing more reworking, and we're going to do more refactoring. So it's really important to set up your project to empower these tools to give you code that when you look at it with your eyeballs, it's the same code that you would have written. Now, you're going to have some bugs you have to work through. You're going to have issues, but you don't want the tool generating code for you where when you look at it, you say, ugh, that's not the code that I would have written, because then it's just trash. And always do it on a feature branch so that you can throw it away and start over. Okay. Also, I emphasized again, you gotta have the quality or you're going to get burned. All right. All right. So I know this is a whirlwind. It's kind of exciting. And this is just the tip of the iceberg. Sign up for our .NET AI driven development bootcamp, December 8th through the 10th. And we're going to be going deeper, and we're going to do more of these webinars. So, so sign up there, and I'm sorry I used up all the time. Didn't have time for questions. But I just wanted to wet your whistle because this is a big topic, and I hope all of you will We'll try out more things that you can do with Copilot and improve your process. But if you don't have a fully DevOps automated DevOps environment, work on that first. Okay. Thank you all. Have a great day, and I'll leave this slide up for a bit so that everybody can take a picture of it.